Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit... Oh, didn't mean to do that, sorry. This is Unit 1, Lesson 3, on piecewise functions. So this is how you spell that, piecewise functions. Now these things are a little bit interesting, and you need to pay attention to understand how to solve certain problems. So, we already reviewed, and you should know this from Algebra 1, that you can graph lines like this or like this, and there's certain parent functions that we'll learn in the next video, but piecewise functions are when you graph a line, but sometimes there's different parts. So, for example, in the older days, not when I was around, you had to pay money for a certain amount of time that you talked on the phone. So let's say that this is not going to be accurate. I don't know what the actual rates were, but let's just say it's $60 an hour. $60 an hour to talk on the phone. But once you get to 5 hours, then it is $61 an hour. Let's just say that. That's just kind of random. But there is a certain function that would graph, and you could graph that, and it might have something like this. And then something like that, because there's a certain portion that's not going to be labeled. So that might not make sense, but let's look at what it looks like. So, remember, we learned about functions in the last episode, or maybe it was episode 1, I kind of forgot. Or not episode, lesson, sorry. So, fx basically just means y. That's the same thing. So, if you're trying to find y, just find fx, or the other way around. And then there's just x, and x is x. So, what a piecewise function might look like is you have fx, and it could be something different. It could be, we already talked about this in the last lesson, it could be gh, or anything like that. But then you have this big open brace, and there's different things within that. So let's just make up an example. Okay, so we have two equations here, and they depend on what x is. Okay. Now, to review, when you have the greater than and less than signs with nothing under them, then you will use the open dot. Open dot means it's not including the dot that it's on, and that means you will use parentheses when stating the domain and range. But if you have greater than and less than sign with lines under it, that means greater than or equal to, which means it is including it. So then you do a dot filled in, and you would use brackets. Also, if you use infinity, you will have, or negative infinity, you will use parentheses, not brackets. So, what does this mean? What does this strange thing mean that I wrote? And it might not seem strange to you if you already know what this is. Some people might have learned this in Algebra 1, others not. So, basically, this is saying you will be given x. So, let's just say, for our first example, that x is 5. Okay? X is 5. Based on what x is, you might want to use this equation or this equation. And there can even be more than just 2 there. But you have to look at this, the if blank, to see which one you're supposed to use. So, if x is less than 1, use this equation to solve for fx or y to find out what that is. Okay? But is 5 less than 1? No. So we're not using that one. If x is greater than or equal to 1, then use this equation. Is it greater than or equal to? It's not equal to, but it is greater than, so we use that one. So we plug in 5 and then add 4, so that's 35 plus 4. Therefore, fx is 9. Or sorry, not 9, 39. And that's also what y is. So that's pretty simple. That's all you have to do. Let's look at it another example. So now let's say x is negative 19. That's less than 1, so we use that one this time, this one. So we plug in negative 19. Okay. 5 times negative 19 is negative 95. Minus 2 is negative 97. There we go. So now you can see that's what you do. It doesn't matter what equations are there, that's what you do. Now let's go over to the graph, because I have a graph this time. So here's a graph. As a reminder, when you're in this quadrant, it's positive coordinates. In this one, it's positive, negative. In this one, it's negative, negative. In this one, it's negative, positive. There. Okay, sometimes you have to graph these piecewise functions, so let me look at my examples of problems thing and see what we do. Okay. Here is an example. Okay. Well, I don't have a whole bunch of room to write down here, but I'll try to. So let's actually use blue. Fx is equal to, we have a brace here, and the first equation we have is 2x plus 2. And then we have 2x plus 3. You use the top one if x is less than negative 1. You use the bottom one if x is greater than negative 1. Not equal to, so that means for everything we're going to have open dots. Okay? How in the world do we graph this? What in the world? Well, you might think, oh, just graph that. No, it's not what you do. Here is what you do. You need to plug in this value, negative 1, into both equations and see what you get for fx. So I don't have a lot of room to do that, but we should know this by now. So 2 times negative 1 is negative 2 plus 2 is 0. So we get 0 for what what fx would equal in that case. And then when you plug it in for 3, you get 1. So on 1, we get 0, and the other we get 1. So there's something important to realize in this case. So that's what our y coordinates are, but what our x coordinates are is just negative 1. That's why it's there. So we have coordinates here. These are end coordinates. End coordinates. So that means it will either have an open dot or a closed dot, but we only are giving, there's 2 parts to this piecewise function. So there's going to be 2 different lines we draw, and they'll have an end that's open because there's no line under the less than or greater than signs. So it will be an open circle, and there will be an arrow on the other side because we're not given the other end. So we just have to assume that it goes on forever. But we need to know which direction, because the arrow could go this way, this way, this way, or this way. Here's what we know. So here's what we think about. So we see right here on the first equation, x is less than 1. Less than 1. So here's negative 1. Or I meant less than negative 1. So that means it's going to be values to the left of what x could be. That means that that arrow is going to point to the left. But it's not just going to point to the left. It will have to point up or down. How we know if it points up or down goes over to the slope. Here we have a positive slope, but in this case we will not be going, the arrow will not point up, because here's why. That with the piecewise functions, they can't necessarily go like this. They need to go in the same directions like that. So when you can look at the slope, but the piecewise functions are going to go like this or like this. So it has to point down, because basically I mean they have to go like this or this. But in this situation, because it cannot point up like this, because it needs to go, when it's pointing to the left, it needs to be down in this case. So we're going to go left and down. And then for the other one, we're going to go right and down. Why right? Because x is this time greater than 1, so that means it's got to be pointing that way. It could be pointing the same way. Or sorry, not down, up. Didn't mean to do that. It can't be pointing down. So now we know what to do. All we have to do is plot this point and draw arrows going both ways. So -1, 0 is right here. We do an open dot because there's no line under that. Then we said it's going to point left and down, but we can't just randomly draw this. We have to look at the slope to know how far to draw it. So that's 2. So 2, that really equals 2 over 1. And slope is rise over run. Or you could just say y over x. But, so that means we need, rise is if you go up or down, and then run is left or right. So we're going left and down. So that means we go down 2, and then we said left 1. So down 2, left 1, here. 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 And then here. So now we can draw this full line, connect these dots, and we're only giving one end, so we know that it's just going to go infinitely that way. Talk more about that in a minute. So now we need to plot this point, -1, 1. So that's going to be right above that. It's also going to be an open dot because, there is no line under that. Oh, this thing's messed up. The slope is still 2, so 2 over 1. But this time we're going up and then right. So we go up 2, right 1. Okay? So up 2, right 1, here. Here, here, here. Then we can connect these dots, and it goes infinitely that way. There we go. We just graphed this piecewise function. That's how you do it. But in some cases, you'll have to name the domain and range. So we already talked about this, but to find the domain, it's how far does it go left and right. Well, we know that it goes infinitely this way and to infinity that way, and that's left and right. Even though that kind of looks like down and up, it's really left and right, because eventually that would go all the way to infinity. But we have to consider, is there any spot that it skips in between the two parts? No, because they have the same x value, -1. So we can say that this is goes from negative infinity to positive infinity. And like I said before, when using infinity, we have to do parentheses. Let's look at the range now. So we can tell that it goes from negative infinity to positive infinity. But are there any parts that it skips? Well, yes. It skips the area from where there's a y point of 0 to 1. From that spot, 0 to 1, there is no y point. So we have to have two parts here. We have our first part that goes from negative infinity to 0. And we use a parenthesis because that's an open dot. We would use bracket if it was closed dot, but it's not. And then we have to say u. That just means and, because there's another part. Then we go from 1 to infinity. There we go. That's our domain and range. And that would be it for piecewise functions. That's how you solve these problems, and hopefully this made sense. And stay tuned for my next video on parent functions.